We're continuing to look at inferential statistics. And so if you've taken a stats class, you know a number of statistical tests. The key here is to know when to use different ones depending on what you're exploring in the data. In our previous videos, we looked at when we have one group and we were comparing to a value, whether it was nominal, ordinal, interval, or ratio. We used the chi-square, Wilcoxen, or one sample test to compare either the groups to expected numbers in each group, to compare the median response in, say, a Likert scale opinion poll to what we think the median would be, or to compare the average of when we have ratio or interval. And then in the last video, we looked at what if we have two groups and we have different people in each group. Then we looked at if we are comparing their responses in a binary question. So here, this is yes, no, true, false. The two different groups, do they feel differently? Do they have a different percentage of yes to no in this nominal? And then with ordinal, we're looking at responses to Likert scale survey type questions where we're asking about their opinion. Do two different groups have a different opinion? And that's what we're looking at Mann-Whitney with ordinal. Do we get a different median response for the two different groups? And if we have ratio or interval data, is the average response, so here we looked at years with the company, is that different between the two groups? So let's look in this video at what if we have two groups and we have the same people in both groups. So we have paired data. The idea is that we've asked two types of questions to the same group, maybe over time. And so we want to see if the responses have changed between the same people, right? So it's paired. Think about it as like a before and after test. So before and after some event, has the opinions changed? Has the measurements changed? Has the categories changed? So same people in both groups. If it is nominal, so it's categories that we're comparing, have the people changed in the category, it's a McNemar test. If it is the same people in both groups and it's ordinal data, typically we're looking at like Likert scale opinion polls, then is there a change in their opinions, say before and after? And then with ratio or interval data, we have measurements or counts. Is there a change in the measurements or counts if we're doing before and after? Again, with the ratio and the interval, we have a test if we can assume normal distribution. If you can't assume normal distribution, so if we can't assume that it's centrally located and then the probability of responses gets smaller and smaller the farther you are away, then of course you downgrade to ordinal and use the Wilcoxen Rank Sum test. We could go on, there could be 7 zillion videos about statistics where we look at how do you test if it's normally distributed. And maybe in the future we'll have more detailed videos for all those components. But right now, big picture gloss over, here's the tests, here's when you use them, and you can explore that further. All right, let's go in. We're looking at McNemar, Wilcoxen, and a paired T. So let's go into our data set. All right, working through the middle of the Inferential Statistics workbook. Just a reminder that this comes from drstephpowers.github.io/BIA. We're using the Inferential Statistics from the Chapter 5 of the Business Intelligence and Analytics Handbook. We're using this workbook. What we're going to be doing with this, because it's paired data, our survey doesn't work because our survey is a cross-sectional survey, which means that we did it once at one moment in time. Paired tests are the same people who are answering the same questions, so we need measurements typically over time. So in fact, what we're going to be using for some of these questions is the data set that is the CRM Clean. You can find CRM Clean here in GitHub. Download it, put it into your Google Drive. If you're using if you're using, say, Blackboard or other learning management systems, we can post that Excel file in there. And you'll need to then mount your drive, import it in, so we can use that particular data set, because this one is a customer relationship management data set, which means we're recording what's happening with our communications and relationships in 1 month, the next month, and so on. So we can see if categories change, we can see if Ranked data changes if measurements and counts change. All right, so let's go in to our data set here. So we are, again, let's just go back up. We mounted our drive, we imported, and we're going to call this DF3. So this is just data frame number 3. Call it whatever you want. Just remember to refer to it that way throughout. All right, make sure you're referencing where it's located. I put it into the folder BIBA Handbook in Chapter 4 folder inside that, and it's called crmclean.xlsx, and we're using sheet 1. So if you don't specify sheet 1, it won't give you the data. All right, let's go back down. We did Fishers. Got too much in the workbooks. They gotten very big. All right. Differences between two groups, same people in each group. First one is a McNemar test. All right, there's something wrong with this code. It tells you right away. You can see it on the right. There's this little red thing that says, you got a problem. Something's not working. So first of all, we need to import numpy as NP. And that is because we are going to manipulate the data. And if we look at the data set, actually, let's just take a look at it. So let's go and let's show me df3.head. Remember that default, if you don't specify, we'll give you 5 rows. So what we're going to look at is this information here. And what we have is we have information in 1 month and then the information in the next month. So you can see that this is March, and then there's April, and then there's May data. So we can look at over time the same group of people. This gives us the paired data. Now, what we're going to do is we're going to take questions 6 and 16. So I'm just going to take you back to when we did data dictionaries. We looked at question 6. Question 6 is the stage of the relationship at the beginning of March, and the different categories were qualified, contacted, demo, proposal, negotiations, won, lost. Okay, and we're going to compare 6 to question 13, customer relationship health in March. Make sure that's right. Or 16, sorry. That doesn't make any sense. 16. It should be the same question. So 16 is the stage of the relationship at the beginning of April. So what we want to know is, has the relationship changed from March to April? That's what we're looking at in this question here. All right, so what we're going to do is we're going to create a copy of DF3. And the reason we're going to create a copy of this data frame is that we're going to change a bunch of stuff. And I don't necessarily want that stuff permanently changed. I want to change it now for this purpose, but I might want it in its original form later. So I'm essentially making a copy of that table, and we'll call it MN because we're using it for McNemar. You can call it you can do it whatever you want. Now, what we're going to do is we're going to take this new copy and we're going to replace where it says qualified, we're going to code it. Qualified equals 1, contacted equals 2. Notice that if you have typos in the words, then it's not going to code it correctly. So qualified 1, contacted. Now, what we have here is I'm actually just going to create 2 categories because to do the McNemar, it is like the Fisher's exact where we basically need to have 2 groups. Sorry, we have we're comparing our time, we're comparing March and April, but the categories have to be 2. So it's the 2 by 2 that you saw with the Fisher's exact. So what we're going to do is we're going to take qualified and contacted. That's the people that we think might be potential customers, but we haven't enticed them in yet. So we'll call them 1s. And then anybody we're in process of negotiating with, demo, proposal, negotiations, won them as a client, we'll do 2. So relationship, no relationship. And if we lost them, then we'll exclude that from this. We'll call it NAN. So the other reason for our numpy as NP is to then be able to just zero out essentially the lost ones to make it not part of this data set. So we're gonna put people into the category of either we don't have a relationship with them yet to we have a relationship with them. And what we want to know is whether those categories change over time. So if we look from March to April, is there a change in that category? So we're going to relabel these. So we're coding them here, 1s and 2s. And then we're going to do in place equals true. Because we have created this copy of this data frame, rather than add new variables, we're just going to take this copy and we're going to replace these sections of it. So if I run this, and of course it works because I already imported numpy as np, I didn't really have to do it again. But let me just add here to show what mn looks like. So mn is the full table, but what you see for question 6 is you're only going to see 1 and 2s. And for question 16, which is kind of hidden here, you're only going to see 1 and 2s. Okay, we've relabeled them all as 1 and 2s. You want to see question 16, we would just do mn question 16. Make sure you put a Q in front of that. There we go. If you do that, you can see they're all 1s and 2s. Okay, all right. So now we're going to build our crosstab. Again, we need a 2x2 table to do the McNemar, just like the Fisher's exact. So from pandas, we're going to import crosstab if we hadn't done it already. Technically, we already have it imported from our previous video. Then we're going to create the crosstab. We're going to have on an index our question 6, and for our columns question 16, we just need a 2x2 grid here. Okay. Now that we have our 2x2 grid, we're doing the McNemar test. And what this is going to tell us is whether or not between March and April, has there been a change in the no relationship categories that we have here. So we need to do McNemar, and McNemar comes from statsmodels.stats.contingency tables. Because a McNemar test uses the contingency table to do its analysis. So what we're going to do is from statsmodels.stats.contingency_tables, import McNemar. That's the package we need. And then the McNemar one's a little weird in terms of getting its output. So you actually have to tell it to print McNemar. And then we need it to provide it the contingency table. We're doing exact equals true and correction equals to for this. So it's this one's a little weird in terms of how you call it in order to get our values. And so what we find here is we find that we have a p-value of 1.5, and then we have engineering notation of negative 0.05, which means we have a very, very small p-value. And so what this tells us here, because remember, if you have a small p-value, we have a difference. And if we have a big p-value, we have no difference. So what this is telling us is that this relationship, no relationship in March changes when we get to April. So notice in the contingency table here, we have that in March, there's a lot of organizations we don't have a relationship with, and then by April we have a relationship with a lot of them. Some of them we may have lost, but we don't have a whole lot that are in the no contacted stage. So we can see that over time here there's been a change in their category, in their nominal value. Okay. If we have two groups, so paired data, but we're looking at ordinal instead of nominal. So if we just go back to our image here. Come on, load up. There we go. So we have two groups, same people in both group, and we have ordinal data. Then we're doing a Wilcoxen Rank Sum test. So let's look at how that works. So in order to do the Wilcoxen Rank Sum test, we're going to take our variables 16 and 26, and we are going to code them because in the original data set they are not coded, right? They say qualified, contacted, demo, proposal, negotiations, 1 lost. And if we're doing ordinal, we want to make sure that there is an order or ranking to them. So we'll do qualified 1, contacted 2, demo 3, proposal 4, negotiations 5, 1, 6. We will make the lost NA, not applicable, remove it because that's not part of the transition. A contract could be lost at any point after the demo, after the proposal, and so on. So because of this, we will remove the lost from this rank transition period here. So we're going to take our DF3, that is our customer relationship management database. We're going to create a copy because we might not want these changes, these codings to be this way for other tests. As we saw in the previous test, we wanted it coded differently for that one. So we're going to do WN. So we'll do WN for Wilcoxen. You can call it whatever you want. And I'll just call it WN here. And then I'm going to take WN in our new data set. And I'm going to take question 26 in that new data set. And I'm going to replace qualified with 1, contacted with 2, demo with 3, proposal with 4, negotiations 5, 1, 6, and I'm going to make lost be the NANs. So we need to make sure we are running the package numpy. So we've imported that before, but if you don't have it running because you're just doing this test for the first time, then import numpy as NP first. We'll do the same thing to question 26, replace the words, the text with coded information and remove the lost. Of course, in place equals true because we are just putting it into the new data set and replacing it as opposed to creating a new variable. So we run that and we can see here with our new table that question 16, it's kind of hidden here, but question 26 you can see is now coded 2, 3, and so on. Now, in order to do the Wilcoxen Rank Sum test, anytime you have paired data, you can't have one set of information and not have the other. So we can't have a data point for question 16 and then not have the data point for question 26 for that same person or event. We need to have both pieces. So we need to drop the NAs from the table. Now, if we just took the full data set WN and dropped the NAs, it would drop every row that contained an empty value. And that might be for variables we're not currently looking at. So we're going to take our table WN and we're going to create a smaller table called WN2, which is just questions 16 and 26. And then from there, we'll drop the NAs. So when we do this and run this, let's just say, show me this. What you see is we now have a table that just contains 16 and 26, and it removes all the rows where there is not information for both question 16 and for 26. So now that we've done that, we can do our Wilcoxen test. And so here we want to know is there a difference? And here we're looking at the ranking. So is there a difference in where the relationships are at between, so question here we're looking at March and April. In our previous one that we just looked at, you know, we had turned it into relationship, no relationship, and we happened to be looking at questions 6 and 16, so that would have been March and April. Now we're doing a similar test, but here we're treating the data as ordinal, so not just relationship, no relationship, but we're looking at it as it transitions. And so let's just look at instead April, May. So what we're going to do is we're going to run our Wilcoxen. It comes from skippy.stats. So from skippy.stats, import Wilcoxen. That's the test we're doing. And then to do the Wilcoxen, we just take WN2. That's the new table that just contains those two variables, so we could remove the empty values. And we're looking at question 16 and question 26. We run that. We get a p-value that's 5.35. We have our engineering notation saying to the negative 13. That's a lot of zeros between the decimal and the number 5, 0.0000, all the way to get to that 5. So the p-value is very tiny, which tells us there is a difference. there is a difference between the rankings that we're seeing in April and May. Okay. If we have data that is ratio or interval, then we do a paired t-test. So if we just go back to our chart quickly here, two groups, same people in both groups, ratio or interval data. If we can assume normal distribution, then we do a paired t-test. If you can't assume normal distribution, if the distribution is unknown, we use the Wilcoxen Rank Sum test. Again, normal distribution, it has an average, and the farther away you get from the average, the reduced probability or likelihood of a particular number. So if you have skewed data, if you have uniform data, then you should be using your Wilcoxen Rank Sum instead of the paired t-test. All right, let's go back to our data here. So to do a paired t-test, we're doing, the command here is t-test_rel, so a t-test where they're related. And we are going to need to get that from skippy.stats. So let's import our packages first. Import numpy as np. From skippy.stats, import t-test_rel. So that's the packages that we'll need. And then again, when we have paired tests, we need to make sure that the information is present in the variables. So in here we have two groups. So we're going to look at question 7 and question 17. So we'll just go back to our slides here. And let's look at our CRM data. So question 7, the talk to listening ratio for March. Question 17, our talk to listening ratio for April. And so that data is going to be percentages. So we can, we have ratio or interval data. We'll assume that it congregates around a average. So there's a typical talking ratio that's more likely. All right, so with question 7 and question 17, because we are comparing March and April, we need to make sure the data is present for both March and for April. And so what we're going to do is we're going to create a subset of the table. So we take df3, and we're only going to take question 7 and question 17. That's what you see here with the double hard brackets. And then we're going to drop the NAs, and that's going to create a new table for us we'll call pair T. You can take a look at pair T, of course, by just doing pair T. And we can see here we have our two columns. Okay. And then to do our test, we do t-test_rel, and then we simply call in those two variables. So here's question 7, question 17, and we run that. We get a p-value here of 0.003. This is telling us that they are not the same. And so we can actually just look here, and you can see that as we compare, remember these are each row is one person. Some people look relatively the same. But others, there's a change. And so what it's looking at is on average, we are seeing a difference in those two variables. And so this p-value is less than 0.05. There is a difference. Now you might want to see, okay, well, is that, if we go back to our question here, 7 and 17, we're looking at the talk to listening ratio. And so maybe we are assuming that over time, there is going to be less listening, more talking by our salesperson. So we're measuring this here in terms of percentage of time the salesperson listens per minute. So we have this expectation that the listening is going to decrease as we get to demonstrations, as we start to do more negotiations. In the beginning, there's lots of listening because we want to know what the customer's concerns are, what their needs are. So here we can do the same paired t-test, but we can have an alternative of less. The idea here is that the numbers are going down for whatever you put first versus what you put second. So let's run that. And we can see that that p-value is less than 0.05. So it looks like on average, there is less listening happening as we transition from March to April.